Please put down. Isotopes are atoms with same atomic number slash proton number. They are atoms with same atomic number slash proton number but different mass number. They are atoms with same atomic number slash proton number but different mass number. Full stop. Now let me give you an example of an isotope. When they say first, before I proceed to give us an example, it's important for us to understand what atomic number is and what mass number is. Now let's take this to be the general representation of an atom, right? You've seen this in your secondary 2 textbook. Now, the subscript, we have Z, the superscript, we have M. Now, this Z is the atomic number of that atom or the proton number. Please note that atomic number of any atom is the same thing as the proton number of that atom. Take note of that. Where M here is the mass number. Another name for mass number, we can also call it nucleon number. Alright, so we have the mass number, we have the nucleon number. Now, having said this, it simply means that if you see something like this, let's say chlorine, we have 1735. We have chlorine, we have 1737. Two of them, they are isotopes. Why? Because if you look at the atomic number, the subscript, which is this Z, right? This is the Z here. This guy is 17, this guy is 17. So both of them are the same. So in this case now we said, since both of them have the same atomic number, the only difference between this first guy and the second guy is this one here. This is 35 and this is 37, isn't it also? So these two guys, they are isotopes of each other. We also have another example, carbon. We have carbon 612, we have carbon 613. Now this is, both of them, they are isotopes. Same atomic number, 66, different mass number. This is 12 and this is 13. But in exams, guess what? They will not ask you this kind of question. So, and one of the advantage of me teaching you guys is that I'll be exposing us to the various ways question can be asked, so that once you start using your past questions, you know where you should focus your attention on. The first area of possible questions would be all right. So this is that's, like I said, that's one of the advantages of learning with us. So I don't just teach you isotopes and then expect you to go and unravel the areas of possible questions. So for every topic I introduce you guys to, I'll show you the various ways questions can be asked. Please look up. Now, these are the various ways questions can be asked. The first one is determination of protons, neutrons, and electrons of an atom or an ion. Now, the next one would be determination of a chemical symbol when protons, neutrons, and electrons are given. And the fourth one will be calculation of relative atomic mass or average atomic mass. The fifth one would be calculation of percentage relative abundance. So let's start with the first one. Now, what are the various ways in which questions can be asked based on this? Determination of protons, neutrons, and electrons. Class, first thing first, you need to know that proton number of any atom or ion is equal to the atomic number of that guy. And of course, we know the atomic number is the number that differentiate elements in the periodic table. All right. Now, how do we solve electrons? Electron number, or the number of electrons, is equals to proton number minus charge. Now, how do we solve for neutrons? Now we have that mass number is equals to protons plus neutrons. Now, if you make this guy subject of the formula, so therefore, neutrons, which is same thing as neutron number, is going to be equals to mass number minus proton number. So with these formulas now, all you just need to do is locate the various values and substitute it, which I'm going to start with an example afterwards. All right. So that is it. So please let's write down neutrons. All right. Now let's look at these examples. I just want to use this guy. Let me give us a sample before I clean this up. Let's say, for example, they gave us Al 3 plus. Most of the times, they will not give you the atomic number and the mass number. Majority of times, they'll always give it to you. So let's assume this is 13 and this is 27. They'll always give it to you now. They said, determine the subatomic particles in this ion. If you're asked to determine the subatomic particles, that means the particles that are contained in an atom, electrons, neutrons, and protons. That is if they are not spelling it out directly. So first thing you're going to do is that, okay, they're asking me to find an electron, proton, and neutron. So the first thing I'm going to do is my proton number, my protons will be, remember based on that stuff I gave to us earlier, the Z was the proton, is it not so? Which is the atomic number. The subscript is always the atomic number, or which is proton. This is 13. Now electrons, which is same thing as electron number. Electrons, I said, proton number. What is proton number here? 13 minus charge. What is the charge of this compound? 3 plus 3. Please, the sign is very important. 13 minus 3 is how many? 10. That means electron is 10, proton is 13. Now neutron, based on this formula, I said neutron number, which is equivalent to neutrons, is mass number minus proton number. The mass number is always the superscript, right? Now, what is the mass number in this case now? 27. So I'll say 27. What's the atomic number here? So 27 minus 13 is equal to what? 14. So that is it. How many protons? How many protons? Now, imagine they had given this to us and we are asked to find the proton, electrons, and the neutron. So it's basically the first one. I'm just going to do this guy and then the last one. I don't have to do all of them because once you understand the concept, you should be able to do the rest. Is it not so? So for the first one, we say 40 Ca2 plus 20. So I'll say protons, electrons, and then neutrons. Now, protons is same thing as atomic number, which in this case is always what is written as the subscript. Here is how many here? 20. Electrons has a formula, which we're going to say protons minus what? Charge. Now let me say this now, class. Anytime an ion, anytime they give us something that is positively charged, please listen to what I'm about to say now. For a neutral atom, like in this case, where there is neither positive nor negative, the number of proton and the number of electron is always the same, right? Now, for a positively charged, proton will be higher than electron by the number of the charge. I repeat, this guy is a positive charge. Now, in this case, now it means that, remember, protons are the positively charged species, and also electrons are the what? Negatively charged. If both of them are equal, they will cancel out each other. So that particular atom becomes neutral. But if proton, if you have positively charged, it means that electron is actually shorting. So listen, anytime you see a plus, it means that proton is higher than what? Electrons by the number of charge. That means in this compound now, proton will be higher than electron by how many? 2. Now look at this. Proton is 20. Electron is how many? 18. Class, for a negatively charged ion, electrons will be higher than protons by the number of charge. Is it not so? So let's look at this next guy. Now for the second guy, I'm going to skip this guy. I would like us to try the second one because it's very similar to what I did here. Now, so let's look at III. Now look at this. There is no charge here. So first thing I'll say, protons is same thing as the atomic number. Electrons is protons minus charge. And we have neutrons to be mass number minus. So I'm just going to continue from here. So the proton in this compound is 11. We have 11. Electrons in this compound would be proton minus charge, which is 11 minus. Now look at this guy. Is there any charge here? There is no positive, there is no negative. So this is going to be minus 0, which is equal to what? 11. Now that is why, if you could remember, I said that for a neutral atom, the proton is always equal to the what? Electrons. Now the last guy, for the neutrons, what is the mass number of this guy? What is the proton number of that guy? So this becomes 12. So therefore, this guy becomes 11 proton, 11 electron, 12 neutron. Now let's look at the fourth guy, IV. Now we have 35 Cl minus. Now the proton here is 17, which is this guy. Now the electrons is proton minus charge. I already gave us the formula in previous cases. So electron is proton minus charge. The proton in this case is 17 minus. The charge in this case is minus 1. Please, you have to indicate the minus. Minus minus is plus, right? 17 plus 1 is what? 18. Now the neutron becomes equals to, neutron is mass number minus proton, right? So the mass number here is 35. Determination all right. So this is what we have here. Determination of symbols when subatomic particles are given. Class, this is basically like the opposite of what we just completed now. In the first case, they gave us chemical symbols in terms of neutral atom and also in terms of charged atom. And we are asked to give the subatomic particles, the protons, electrons, and the neutrons. All right. So basically, it's just like the opposite of what we did. So this time around, they'll give us those subatomic particles and asks us to use those combinations and form the chemical symbol. So just like the last one we just completed now, I'll say, example, give the chemical symbol ethene electron and what? Now this is just like the opposite of what we did. So the first one, like I said, they gave us chemical symbol in terms of neutral atom and in terms of charged atom. All we just needed to do in the first case was for us to find the number of protons, the number of electrons, and the number of neutrons. So in this case now, it's just the opposite of that. This time around, they are giving us the subatomic particles, and they are asking us to create or to form the chemical symbol. So the first thing I'm going to do here is I need to know the proton number because each atom has their own proton number. You can see two atoms or two species having same electron numbers. Those kind of species, we call them isoelectronics, but you will never see two atoms having same proton number. So that's the same way. No two atoms can have the same proton number. No two atoms can have the same atomic number. So let's look at this guy. I'll say solution. I want to give the chemical symbol that have these subatomic particles. So the first thing I'll say, proton, for the first one, I'll say I, 17 protons, 18 electrons, and 18 neutrons. So I'll say proton, which is same thing as atomic number, equals to 17. So I'll ask myself, in the periodic table, which element has atomic number of 17? It's chlorine, right? So this becomes chlorine because chlorine is the only atom that has atomic number of 17. Now, what if in a case where you do not know the atom that has such atomic number, you use X as the general symbol? If you don't really know the atom in question, use X. If you know the atom in question, use the atom. So since 17 is within our reach, that's why we know it is chlorine. The next thing I'm going to do here is, please look up. I've gotten my proton number. Recall, if I want to get a chemical symbol, this is what I'm looking out for. I need to know what my atomic number is so that I'll attach it here. I also need to know what my mass number is so that I can attach it. Is it not so? In some cases, I need to know whether it is plus or what? Minus. If it is charged, in some cases. All right? So let me just erase this top side of the board so that those of us at the back can have a clearer view of what we're doing here. So I said, basically chemical symbol is actually this. You need your Z, you need your M, and we can actually tell if it is a charged atom, well, we're definitely going to include whether it is net minus, plus, or minus whatever, or plus whatever. So this Z is the proton number, the M is the mass number. So if you want to get the chemical symbol, what are the things you should look out for? The things you should be looking out for is the proton number, which is this Z, so that after you must have done that, you put it here. The next thing you should be looking out for is the what? Mass number, which is the M. And I can remember I gave us mass number to be proton plus what? Neutrons. Now the next thing afterwards, this guy is charged. Is a what? Charge. If the charge is equal to 0, that means that guy is a neutral species. And how do we solve for charge, class? Charge is proton minus what? Electron. That's the formula for charge. Take note of that. I said, if you want to get your chemical symbol, this is a general representation of a chemical symbol of an atom. This Z stands for the atomic number or the proton number. This M stands for the mass number. And this N is actually optional depending on whether that particular guy would have a charge. If that guy doesn't have a charge, here, nothing will be here. All right. So the three things we should solve for to be able to get our chemical symbol is proton number, which we don't have to solve for. They will give it to us directly. Mass number, we have to solve for it using proton plus neutron. And of course, the charge, which is going to be proton minus what? Electron. All right. So let's come back here. So having said this, we'll now say, from here now, my proton is equal to 17. And proton is same thing as atomic number. Which atom has 17 as atomic number? Chlorine. Now the next thing I'm going to say is mass number. Mass number is proton number plus what? Neutron. Class, what is a proton number in this guy? 17 plus class. What is a neutron number here? 17 plus 18 is what? 35. The next thing we're going to solve for is charge. Now, the formula to solve for charge, Baron, how you doing now? The formula to solve for charge is proton minus what? Electron. Now, what is a proton in this case? 17. What is the electron in this case? 18. 17 minus 18 is equal to what? Minus 1. So now look at this. For me to get my symbol, the atom, I'm going to come here, put the atom. Remember, the atom is representing this X, right? Now, what is going to be this Z? Z is going to be what? Proton number. This Z is our proton number, right? So I'll come here and put 17 here. This M is our mass number, which in this case is how many? What is the charge here? I'm going to put the charge at the right hand side, but I'm not going to put the 1. If it is 1 plus or minus, I'm just going to put the sign. So this is it. So this is a symbol for these subatomic particles. And it's just the opposite of what we did previously. As the next question was 20 proton, 18 electron, 20 neutron. This was the second question. So first thing first, I'll say my proton, which is same thing as the atomic number. Is equals to 20. Which atom has atomic number of 20? Calcium. Now, so the next thing I'm going to say is, I'll come here, I'll put calcium. The next thing I'm going to solve, because this is what I'm looking forward to achieve, the chemical symbol, I need to know the proton number so that I can attach it as a subscript. So since this guy is calcium, I put 20 by the side. Now, how did I know? I said proton number is always characteristics of every atom. No two atoms can have same proton number. So the next thing I'm going to solve for is mass number. Mass number has a formula of proton plus neutron, of course, which they gave us in this question. So I'll say mass number M is equals to, now proton is 20, neutron is how many? 20. That's how many? 40. So I'll come here, I'll put 40 here. The next thing I'm going to solve for is charge. Now, charge is proton minus electron. Now, what is a proton here? 20 minus, how many electrons do we have here? 20 minus 18 is what? 2. But since it is charge, plus, you must put the plus. So you come here, you're going to put the charge as a superscript on the right. This now becomes 2 plus. And that's the chemical symbol for that. And we are done with that part. All right, so we have this. Now, calculation of relative atomic mass. Most times, some textbook will call it average atomic mass. All right, this is basically where we combine the isotope mass of both of them to get just 1 molar mass. Like someone had asked me earlier that chlorine has a molar mass of 35.5. Yes. So that 35.5 is obtained when we combine the mass of the first one and the mass of the second one, putting into consideration their percentage abundance. Because one of them occurs at 75%, one of them occurs at 25%. So the one that is occurring at 75% is more abundant than the 25%. So that is why the molar mass of chlorine tends towards 35, because the 35 is more in abundance than the 37. So please look at this. The write-up says, this is a calculation of relative atomic mass when isotopic mass and their relative percentage abundance is given. Now the formula for that guy, I'll say for 2 isotopes, because we have 3 isotopes. 2 isotopes simply means 2 atoms with same atomic number but different mass number. 3 isotope means 3 atoms with same atomic number for different mass number. All right, now this is a formula. For 2 isotopes, this is what we have. Now, for 3 isotopes, let me say this. Now, it's kind of systematic. For 3 isotopes, what I'm just going to do is I'll come here and say plus isotopic mass 3 times abundance 3, still all over 100. Now, the reason why we said over 100 is because the abundance is given to us in percentage. It's given to us in what? Now, if you add up the percentage, it's always going to give us what? 100, right? So even if they had given us 3 isotopes, that's why I wouldn't bother myself for the 3 isotopes, but in exams, my solve question that involve 3 isotopes. But it's very simple. For me to get the 3 isotopes, I'll simply say, this is for the first one, isotopic mass 1 times abundance 1 plus isotopic mass 2 times abundance 2 plus isotopic mass 3 times abundance. That is if it was 3 isotopes. Now, the highest they will ask you guys is 3 isotopes. They wouldn't actually exceed 3. Right? Calculate the relative atomic mass of element X if their percentage relative abundance is 72.16% and 27.84% respectively. I said in this type of calculation, they'll always give us the isotopic mass and the percentage abundance. So in this case now this is the question. They've given us, this is the first isotopes, and this is the second isotope. The first one is 85, the second guy is 87. Now, the mass of this 85 is this. Now, the one you're going to use for calculation is always going to be an approximated value, such that when you approximate, you get the real value here. So this is 84.9. It will always be given to you in such a way that when you approximate the value, you get this. This guy, 87, this is what you're going to use for your calculation. So this is 2 isotopes, and basically this is a formula we're going to use. They gave us, this is the first isotope. How will I know is the first isotope? Apart from the fact that they will always mention it first, the one that have a lesser mass, you consider that one as the first isotope. So I'll say this guy is the first isotope. This guy is a what? Second isotope. Now, the isotopic mass of this guy is 85, is it not so? But the one you use for calculation is not the 85 itself. It is the approximated value, such that when you approximate, you get 85, right? So you come here, I'll say relative atomic mass, isotopic mass 1. Now, this is the first isotope. So the mass of this first isotope is 84.9118, is it not so? So I'll say 84.9118 times, what is the percentage abundance of this same first isotope? 72.16. I'll enclose that part in a bracket. Now this plus, the second isotope is 87. The mass of this second guy is 86.9092. So this becomes 86.9092 times the second isotope, the percentage abundance is 27.84. Now, this is divided by what? Now, let me tell us something, class. The reason why we have 2 types of abundance. We have the percentage abundance and we have the fractional abundance, class. This formula is only used if the abundance is given to us in terms of percentage. Please, when they say percentage, if you add up percentage, it's always going to equate to what? 100. That is why we are dividing this guy by 100. Fractional abundance, when you add them up, is going to equate to 1. I repeat, percentage abundance, when you add it up, it will give us 100. That is why this formula is divided by 100. Fractional abundance, if you add it up, is going to give us 1. So, assuming it was fractional abundance, we would have said divided by 1. But since they gave us this abundance in terms of percentage, that is why we are dividing by 100. Right? So we proceed. Your calculator can do justice to this. Please, the unit is going to be AMU. AMU stands for atomic mass unit. Atomic mass unit. That's the meaning of this acronym. Atomic mass unit. We have another question here. Now look at this question here. I decided to give us the one that has 3 isotopes to correspond to this. If you approximate 15.99, you get 16. That means this mass is for that of this guy. If you approximate 16.99, you get 17. That means this is for this. If you approximate 17.99, you get 18. That means this is the mass for this third guy. So the question says, if the relative abundance of these isotopes are 99 and the rest of them, determine the average atomic mass unit. Remember I told us that relative atomic mass could actually be replaced with average atomic mass. So it's same formula, same everything. Look up, everybody. Please look up. How many isotopes do we have here? 3 or 2? Now the formula is going to be, I'll say, first isotope. I want to get the parameters for the first isotope. The mass of the first isotope is 16 O. The mass of this guy, mass 1, is 15.99468. Percentage abundance 1 is 99.759. I believe you understand what this respectively means, right? Please, have I started that recording? Now, it means that here, 15.99, this respectively simply means these values are actually according to each of as they appear. The first one is for the first one, the second one is for the second one. Now, if the relative abundance of these isotopes are 99.5759, 0.037%, and 0.204. Now, accordingly, this one is for the first isotope, this one is for the second isotope. So I'm trying to actually arrange them. So I'll say for the first isotope, we'll say relative atomic mass for 3 isotopes is going to be isotopic mass 1 times percentage abundance 1, right? Please, since it's for 3 isotopes, this is going to get to the third guy, isn't it also? So plus isotopic mass 2 times percentage abundance what? 2 plus isotopic mass 3 times percentage abundance what? 3. Now this is all divided by what? 100. So I'm going to clean this top side of the board so that I will substitute the values. Now we've succeeded in interpreting or getting the values from the question. So we want to now start inserting. So I'll come here, I'll clean this part up. The mass of the first isotope is 15.998468. So I'll say 15.99468 times percentage abundance 1. What's the percentage of the first abundance? 99.759 plus isotopic mass 2, which is this guy, 16.9984 times the abundance is 0.037 plus isotopic mass 3 is going to be 17.9972 times 0.204. Now this is divided by 100. As simple as that. Please, your calculator should actually help us out here. So this guy's relative atomic mass is 15 point what? 99. So that when you approximate it, it will give you what? 16. A what? Mu. That is that. So, any question on this? Let's look at the last part under isotopes and then we call it a day. Start for why? Not here. determination of relative percentage abundance